Let's be real for a second. Building software, it can get messy, and I mean fast. You've got different teams, the requirements are always changing, and suddenly that crystal clear vision you had just turns into, well, chaos. So today, we're going to pull back the curtain on the tool that was literally designed to stop that from happening. We're talking about UML, the Universal Blueprint for Software.
I mean, just think about it, right? You've got developers over here, analysts over there, clients trying to explain what they want, and they're all trying to describe this really complex system. If there's no shared language, ideas just get lost in translation. It's like a game of telephone. Wires get crossed, features are totally misinterpreted, and that beautiful, simple idea you started with, it just becomes this tangled, confusing mess.
And this quote, it just nails what the world was like before UML. People were just fed up with an ambiguous variety of circles, dashes, stars, and clouds. It was the Wild West of software design. Seriously. Everyone had their own secret code, their own way of drawing things. Imagine trying to build a skyscraper where every single architect has their own unique symbol for a wall or a window or a door. It would be a disaster. That's exactly what software development felt like. You'd get these custom diagrams that literally only the person who drew them could understand.
So, to fix all of this craziness, the industry desperately needed a standard, a common ground for design. And that answer is UML.
Okay, so what does unified modeling language actually mean? Let's break it down. Unified is key. It means it brings together all the best ideas and practices from all those older, chaotic methods. Modeling, well, that's just a fancy word for planning and designing before you actually start building anything. And language? That's the most important part. It means it has rules, a real grammar, a visual vocabulary of boxes and lines that everyone agrees on for describing software.
And, the goals here are super practical. This isn't about making pretty pictures for the sake of it. No way. It's about clear communication, making sure everyone on the team is on the exact same page. It's about exploring different designs on paper, which is cheap, right? Before you commit to writing code, which is, you guessed it, expensive. And this is a big one. It documents the system so that new people years down the line can actually come in and understand how everything works.
Now, UML isn't just one giant, confusing diagram. It's actually really organized. It's split into two main families, structure diagrams and behavior diagrams. And honestly, if you can get your head around this one split, you've pretty much grasped the entire system. It's that important. Okay, this right here is probably the most important distinction in all of UML, so listen up. Structure diagrams are all about the what. Think of them as the static blueprint. They're the nouns of your system. It's like the architectural drawings of a house, right? It shows you the rooms, the walls, the doors, the things that are. Behavior diagrams, on the other hand, are all about the how. They're the verbs. They show how things actually move and interact over time. So, if the structure diagram is the blueprint of the house, the behavior diagram is like a video showing people walking through that house, opening doors, and using the kitchen appliances. What versus how? Simple as that.
So within those two families, how many official diagrams are we talking about? 14. Yep, 14 total. 7 for structure and 7 for behavior. And I know what you're thinking, 14? That sounds like a lot. But don't worry, don't panic. The reality is most projects only ever use a small handful of these to get almost all of the value. So that's exactly what we're going to do. We're going to zero in on the 3 most common, most powerful blueprints in the entire UML toolkit. If you can master these 3, you'll have a huge advantage when it comes to understanding and designing software. All right, first up, we have the king of all structure diagrams, the class diagram. I'm not kidding, this is the absolute heart and soul of any object-oriented design. It describes the fundamental building blocks of your system, the classes, and just as importantly, how they all relate to each other. Look, if you only learn one UML diagram in your life, make it this one. It's that crucial.
So every class is shown as this simple box, and it's split into 3 parts. Super easy to remember. Up top, you've got its name, something like customer. In the middle, you have its attributes. That's just the data it holds, like name or email address. And at the bottom, you've got its methods. These are the actions it can do, like place order or update profile. It's such a simple idea, but it's an incredibly powerful way to define basically any concept in your system.
Okay, moving on. Next up is our first peek into the world of behavior diagrams, the use case diagram. And this one forces us to shift our focus completely. We're no longer looking at the internal structure. Instead, we're looking from the user's perspective. It answers one really simple question. What can a person actually do with this system? It's all about functionality, pure and simple. And the best part? It is beautifully simple. You've got an actor, which is usually shown as a little stick figure. That could be a person or even another system. Then you've got a use case, which is just an oval. The use case represents a goal, something the actor wants to do, like log in or search for product. And then a line connects them. That's it. It just shows which actors can perform which actions. Think of it like a high-level map of what the system is for.
All right, our third and final essential blueprint is the sequence diagram. Now, if the use case diagram was the high-level map, this is where we zoom all the way in. This is where we get into the real nitty-gritty of how things actually work. It's all about modeling the conversation that happens between different objects to get something done.
The key phrase to remember here is over time. This diagram is like a film script or a comic strip for your software. It shows step by step who says what to whom and in what order. It's all about visualizing that flow of logic for one specific scenario, like what happens exactly when a user clicks the search button.
Okay, check out this simple example here. See how time flows from the top to the bottom? So first, the user sends a search message to the system. Then, the system turns around and sends a query to the database. The database does its thing and sends back the results. Finally, the system takes those results and displays them back to the user. And boom! In just a few simple lines, we've mapped out that entire back-and-forth conversation.
So, we've just covered the big three, and you can already see how useful they are, right? Which of course brings up a very obvious question. If these three are so great, why on earth are there 14 of them in total? And the answer, in one word, is perspective. Think about it. A software project has so many different people involved. You've got architects who need that super high-level 30,000-foot view. You've got the coders who need to see the detailed class view. You've got testers who need to understand exactly how the system is supposed to behave. And then you have customers who just need to understand the main functions. UML gives every single one of these people a specific, tailor-made diagram so they can see the system from the exact angle that matters most to them.
So that's the real magic of UML. Its power isn't just that it's a standard, it's that it can offer all these different but consistent viewpoints into the very same complex system. It's one shared language that lets everyone describe the part of the elephant they're touching while still knowing they're all talking about the same elephant.
And that really brings us to our final, most important takeaway. Please don't think of UML as some boring academic exercise or another bureaucratic hoop to jump through. It's not. It is a powerful tool for thinking. The little bit of time you invest up front in making a clear diagram can literally save you from huge design flaws, nasty bugs, and incredibly expensive rewrites down the road. Bottom line, it's all about planning before you build.
So, I'll leave you with this thought. The next time you start a project, before you jump straight into banging out code, just pause for a second and ask yourself, could a simple blueprint, a quick class diagram, maybe a use case sketch, could that be the one thing that saves you from all that chaos and leads to a much, much better design?